Good morning. So today we are going to discuss about competitive benchmark. Benchmarking is nothing very new. We studied about it. Benchmarking is nothing altogether new. We do it many times in our day-to-day life. Okay. Suppose, say, you might have heard your mom telling you, see, Rahul is securing always the first rank in the class and he has got 100 out of 100 in mathematics. Why you have got just 70? You have heard such comments? I have just asked him, when all 200 people could come to the hall in time, why it took 4 hours, for 4 of you to come late? So what I am trying to do here? I am trying to compare people. How do I choose to compare? I choose to compare you or one particular individual with a better performance. Most often, the comparison is done with the best. In short, this is benchmarking. To put it very crudely, okay, you compare with some better performance, preferably you compare with the best performance, and this is the essence of benchmarking. You do benchmarking ourselves in our personal conduct, not necessarily your mom or dad or your teacher does it to you. You also do benchmarking. Okay. So this comparing with the best practices prevailing among the peers, this is also a way of benchmarking. Now benchmarking is essential in product design. Why benchmarking is to be performed? Next slide please. The objectives of benchmarking are: 1. To understand what needs others are satisfied. There is a spelling mistake over there. To understand what needs others are satisfied. By others, what we mean is our competitors. When we are trying to develop a product, in benchmarking, what we are trying to do is, we have a product which we plan to design. We are planning to design a new product. But many times, such products are similar products, if not identical. Similar products do exist in the market already. Is it okay? If not the exact identical product, similar products do exist in the market already. So what we have to do is, we have to compare the performance of the various existing products so that I can position my product properly in the market. What we are trying to do is, we compare the already existing products in the market so that I can position my product carefully. Usually the end result of this competitive benchmarking is the product technical specification. It is not a very rigorous rule, but usually the ultimate result of product benchmarking is, you are going to design a new product and the technical specification of that new product is the ultimate result. When your mom compares, what is the ultimate result of that analysis? What is the message that she is trying to communicate to you? You also get 100 out of 100 in mathematics. Is it not? She is setting you a target. Usually, benchmarking leads to product specifications. So, at the end of benchmarking, you will say, the product that design now will have this and this features. If I am designing a bike, I would say it will give me 70 kilometers per liter. It will give me an acceleration characteristics of 0 to 100 kilometers per hour in 2 seconds. Okay, or 5 seconds or 10 seconds, whatever it is. Okay, the maximum braking distance will be, say, 10 meters. Okay, from 100 kilometers per hour, it can brake within 10 meters. While traveling at 100 kilometers per hour, if we apply the brake, so these are the technical specifications, not just the voice of the customer. Please remember, there is a lot of difference between voice of the customer and the technical specification. Voice of the customer will not talk in terms of technology. He will not even use the term acceleration. No, speed is different from acceleration. What will the voice of the customer say? Pick up. That is acceleration. You understand? Pick up from 0 to 100 kilometers per hour. How long will you take? Is it going to be 10 seconds or just 5 seconds or 2 seconds or whatever it is? So the voice of the customer will be in layman's language. When you write an assignment on voice of the customer, for many I have pointed out already, you should not use a technical language because that is not the way a customer will speak. Customer will not talk about fuel efficiency. He will not talk about acceleration characteristics. He will not talk about, if it is the case of a cell phone, he will not talk about the various protocols that you use. He will only talk about the bare needs of the customer in layman's language. Right? So we have the voice of the customer. We have identified the various functionalities of the product. Now, we take all the existing players in the market, compare all these players, and then arrive at what we are going to exactly design. You compare the existing players and you finally spell out what is the product that you are going to design. So the end result of this competitive benchmarking is the product specification. The technical specification of the product. I'll show you at the end of the class. Probably I'll show you what the technical specifications are. Now let us see clearly what are the various objectives of the competitive benchmarking. To understand what needs others are satisfying. That is number one. Number two, to improve concept generation. See, later on we are going to see another important topic called concept generation. We have seen the functional decomposition of a product. When you functionally decompose the product, you have got, as an end result of your previous exercise, you have got many black boxes. You have got many boxes. Yes or no? You have got many boxes. What are these boxes? These boxes are the subsystems that you are going to design. Okay. If you recall my previous lecture, I said convert electricity into electrical energy into rotary motion. How are you going to convert? This is going to be the motor that you are going to design. Okay. Reduce speed and increase torque. Another black box will say reduce speed and increase torque. How can that be obtained? That is the output of the gearbox which we are going to design. So you have got many black boxes. These black boxes are to be converted into subsystems by your design team. How is that done? That is done by generating various concepts, various new ideas. Herein comes the role of innovation. Okay, you have to generate new concepts, new ideas, new innovations that will generate some cutting edge for your product. We'll come to that later. The concept generation part will come later. Okay, the concept generation part will come later. The idea is you have to generate, to fulfill the black boxes that we talked about, you have to generate various products, new ideas, new innovations. Now, this benchmarking will trigger this concept generation. How will it trigger? How can benchmarking trigger new ideas? In benchmarking, what you are doing is you are opening up and then seeing. The heart of benchmarking is, the heart of the benchmarking operation is, okay, you buy your competitor's product, open it and see how it works. Okay. If you go to any factory, okay, suppose I have visited some time back the Rane axles. Rane is manufacturing the axles. Okay. If you visit their R&D section, which is somewhere near Vijayanagar, near Velachery, you have the R&D sections of Rane axles. Now, if you go there, in their R&D section, you will see the axles of all their competitors. The moment it comes to the market, they buy it, okay, they open it up, they keep it. The R&D team will frequently see, every time they get into some difficulty, they go and see what their competitors have done in their products. There is nothing illegal about it. Okay. You don't just copy it, but you see what they have done to solve this particular issue. Any product for that matter. Any R&D team will have the products of their competitors in their R&D office. So every time they can refer to and get issues on it. Hyundai does it, Ford does it. In automobile, all automobile majors they do it. All cell phone majors, I mean, without exception, the R&D section continuously, of all the organizations, they continuously benchmark their product. Now, it helps them to generate new concepts and also it lets them know the state of the art. What is the prevailing technology today? And not only of the whole product, but of the various product subsystems, what is the state of the art technology that is provided? Not only of the whole product, but for various subsystems, what is the state of the art prevailing technology? Then to establish product specifications including cost. I told you the ultimate end result of the benchmarking is to arrive at the product specifications including the cost. Generally product specifications doesn't include cost, but when you arrive at some targets for you, no target is meaningful without a cost attached to it. Okay, so you have to correct the cost also at the end of product benchmarking. For executing a detailed design, while executing the detailed design, you have to, there is another important decision that you have to do when you do the detailed design, that is vendor identification. Or rather, it is nowadays called vendor management. See, any product if you take, only about 10% of that is manufactured inside the factory. A few years back, I took a group of students in mechanical engineering to Ford. Okay, this happened because the situation has changed substantially now. But this happened some 5 years back. We have taken a group of students to Ford India. The students were very disappointed because Ford India didn't have any CNC machine. They came and then complained to me, sir, we have one CNC machine at that time. We had only one. We had one CNC machine in our college, but how come Ford doesn't have any CNC machine? They don't have any CNC machine. It has changed now. Now they have opened a new plant called engine plant here, which uses hundreds of CNC machines. No, if not hundreds, tens of CNC machines or no, they have. But at that time, they didn't have an engine division, so they didn't have any CNC machine. See, all the components that are used in an automobile are outsourced, manufactured elsewhere. They are brought to the Ford India and then they are just assembled together here. So, Ford India will decide what all its core operations, that alone will be performed in the Ford India. All the remaining parts, they will be manufactured elsewhere. They will just be taken in and then they will be assembled at the factory here. So, one important issue in the design is the vendor management. How you are going to manage your vendors. So I have to decide for each subsystem or each product, I may have to decide from whom I am going to buy. Okay. And then outsource that particular operation to that particular vendor. Now, the competitive benchmarking will help you in identifying a suitable vendor for some of the subsystems and components that you are going to design. Is it okay? If it is an automobile, suppose, if it is a fuel injection pump or a carburetor, you will not be designing a carburetor or a fuel injection pump. You will not be manufacturing it also. Many times you will not be even designing a fuel injection pump. You will only say, these are all the outputs I want from a fuel injection pump. So that will be a specialist company. For example, Bosch, which manufactures the carburetors and fuel injection pump and delivers it to you. Is it okay? Suppose you have various indicators in your automobile. Okay, you have the fuel level indicator, you have a speedometer. All these indicators are not manufactured. For all the automobiles, they are not manufactured by the OEMs. Ford doesn't manufacture these indicators. Maruti doesn't manufacture these indicators. There is a company in Coimbatore and many more, okay, called Precol. Precol is a specialist in manufacturing various indicators, be it a speedometer, be it a fuel level indicator, whatever it is, engine speed indicator. Okay, so the various dial indicators are manufactured by Precol. So while doing this benchmarking, we can identify who are all the manufacturers of indicators, who is using the state-of-the-art technology. I will just call him and then give him my requirements so that he will design, manufacture the indicators for my product. Are you able to understand? So that is another advantage of performing a competitive benchmarking. In executing the product detailed design, I will be sure that I am using the best-in-class suppliers and components. What do you mean by best-in-class? In manufacturing indicators, who is the best? I can employ him and then have indicators designed and manufactured by him. In manufacturing fuel injection pumps or carburetors, who is the best? I can deploy him. In manufacturing fasteners, okay, various bolts and nuts. In automobile, you will be having thousands of bolts and nuts being used. In manufacturing all these fasteners, who is the best? So that I can leave the design of the fastener, I can leave the manufacturing of fastener to them, so that my overall responsibility is getting reduced. So these are the objectives of doing the competitive benchmarking. Okay. Now the story of competitive benchmarking was officially, I mean, many people would have done it for years, but as a systematic, as a scientific method, it was first employed by Xerox Corporation. Okay. Please believe me, Xerox, what do you do to your book?
Photocopy.
Huh?
Photocopy.
Photo. Actual action is Xeroxing? Xerox is the company which developed the photocopying machine. Now we use, the company is so successful, we use the name of the company for describing the action itself. Okay, but please believe me, today Xerox is not the #1 manufacturer of photocopying machines. They lost their superiority long back. They lost it to Sony. Of course, they have regained some of their lost charm. But the originally in 70s, what is the technology before photocopying? Do anybody know? What are we doing before the advent of Xeroxing machine, photocopying machine? What? Typewriting with multiple carbon papers, you have to do typewriting. There is always a limitation. Okay, the typist, I have seen typists will not generate more than 3 copies because they have to press really hard. They have to really type hard, then only the 4th copy and the 5th copy will get the ink. One option is typewriting with multiple carbon papers. Okay. For engineering drawing, what will you do? For drawings and other things.
Tracing.
No, it is not tracing. The drawings themselves are made on a kind of tracing paper. It is not actually a tracing paper, it is called a vellum. Okay, a transparent paper. The drawings themselves, they were made on a transparent paper called vellum. Okay, then they will take a blueprint of it. Okay, using ammonia, they have a way of taking multiple copies, so you will get a blueprint. The color produced on the ammonium coated sheet will be blue in color, and that is why all the drawings are called blueprints. You have to originally make the drawing in a transparent paper called vellum, then using ammonia printing, you generate multiple copies of that. Okay, of course, you can type it on, when you want to make 100 copies of a written document, of a typed document, what they used to do is, they used to type it on a transparent paper, there is a vellum again, and then they take an ammonia print where you can take up to 100 copies easily. Okay, that is how. So, what Xerox Corporation did was, they revolutionized the idea of taking multiple copies. So they have developed the photocopying machine, but in the 70s and 80s they faced a major crisis. Xerox is basically a US based company, but their Japanese competitor, Sony, they were able to sell the photocopying machines in Japan less than the cost of manufacturing of Xerox Corporation. Do you understand? Sony was able to sell the machine in US at a price which is lower than the cost of production of Xerox Corporation. So what are the additional expenditures involved for Sony? Sony has to ship it all the way from Japan. All the machines are to be shipped from all the way from Japan. Not only that, they are trading in a foreign land, they have to have a distribution network which costs more. In spite of everything, the final price the customer is paying for Sony is less than the cost of manufacturing for Xerox Corporation. And that too, this is not for a small company. A company which revolutionized the concept of taking multiple copies, the concept of photocopying, they pioneered, they introduced the idea. Even that company suffered a lot. So what they wanted to do was, they bought few Sony machines, which were readily available in their supermarkets. Okay. So they studied it. They wanted to primarily study how Sony could manufacture the photocopying machines at such a low price. So this led to a scientific methodology called the competitive benchmarking. And what exactly Xerox did few 20-30 years back, people have started doing for various products to position their product, to identify the technical specifications and all that, and that is what we are going to learn. What we are going to learn is how we can systematically perform benchmarking of a particular product. Next slide please. The benchmarking is done as a 7-step process. The heart of benchmarking is the product teardown, which we have seen. For reasons of our own, we have studied product teardown earlier. Is it okay? We have studied product teardown earlier. It is a 7-step process, and the product specifications, product brochures, and other technical information are also in. The core of benchmarking is you have to take the product, dissect it, dismantle it, tear it down, identify the various subsystems, do the competitive benchmarking. That is the systematic procedure. But what are the secondary sources? The secondary sources are the product specifications of various competitors' products, the brochures, the technical informations, other technical informations available. These are also some of the inputs. Next slide please. There are 7 steps involved. These are the various steps. The first thing is form a list of design issues. Form a list of design issues. Why you want to do benchmarking? What is that you want to achieve? What are the things you are looking for in your competitor's product? So these are the design issues, but how will you get these design issues? We will see later. How will you identify the various design issues that you have to look for? We will see later. Then, form a list of competitors' related products. Your product as such may not exist. Many times, if your product already exists, then what is the point in making it again? For all practical purposes, the product that you are designing may not exist. So, who are all the players in the market? What are all the related products that you have to identify? The next step is you have to conduct a detailed information search. There are various sources of these information. You have to conduct a detailed information search. The fourth step is the most crucial step. You have to identify, you have to perform the product teardown. Then you have to do an important step called benchmark by function. We will see what it is. The sixth step is establishing best-in-class competitors by function. The seventh step is, it is a byproduct, it is not actually a step in benchmarking. So I can also say benchmarking consists of 6 steps. It is a byproduct of benchmarking. You have to plot the industry trends. How the whole industry is moving towards, you can get an idea, you can project and see peep into the future. So that is the last step. Let us see them one by one, and that will be the end of our discussion today. And at the end of the class, you will be given a product for which you have to do some benchmarking. Next, form a list of design issues. On what basis you are going to compare? Your mom chose to compare based on your performance in maths. She didn't choose to compare your looks or your hairstyle or the way you dress. Probably you could have performed much better. Is it not? What is the basis for comparison? The first step is to identify. Your mom must clearly identify where my son is weak, where I need to motivate him, and then she must start talking to you. So the first step is to identify what is the design issue. So where will I know what are the design issues? The best source for identifying the serious design issues that I must address is the voice of the customer. The customer says, I want all these things. These are not existing in the products. These are all the lack now. That gives me an idea of what to look for. Where a gap exists, that is where my product can come and fulfill. Now, you can assign even priorities for various design issues. You can give a number. This is the topmost issue that needs to be addressed. You can assign various priorities for the design issues that will help you to plan better. So, from the voice of the customer, you identify what are all the basic issues that I should look into. What are all the basic problems, what are all the basic requirements I should look into in the various products. Next. Now, who am I going to look at? With whom am I going to compare? You have to always compare with a major player in the market. So, you have to identify first who are all the competitors and what are all their models. And you have to study their market share. You don't want to compare with the loser, is it not? Nobody wants to get identified with the loser. So already there may be a few losers in the market. You don't want to be, in a positive sense, you don't want to compare with them. Probably you would like to study their failures and then learn from their failures, but not in a positive sense. So you identify their market share and find out, okay, with whom you would like to compare. Then you filter down competitors and models. Because benchmarking cannot be done with a large number of products. You may have to do it with, say, optimally some 5 products, 5 different models, or 5 different manufacturers. Probably you can do the product tear down. Otherwise it becomes too voluminous. So you filter down the competitors and models. And this is the second step that you want to pursue. The third step is conduct an information search. That is, gather a large amount of information. Okay? You have to gather information about the products and their related subsystems. Products, and you have to get the related subsystems. What are the functions they perform? And what are the market segments that are being targeted? So that you have to generate the information, because all the informations may not be available as a single source. So the various sources of information are, next slide please. You have the various sources of information. Written sources of product information can be identified in libraries. There is something called thomasregister.com, which is a very useful website. It contains, it is an online yellow page sort of thing. Thomas Register is it is an online registry which contains various product information. You can go to that website and then see. You will get anything that you want. Any legal product under the sun, you can see in thomasregister.com. It is an international yellow page. Then you have various market research agencies. There are agencies which do what is called a market research. They study the market of various products. They provide you information about the market shares. For various products, you have various agencies running these surveys. So you have the market share report. Then you have the National Bureau of Standards, because most of the products, they are governed by codes and standards. You should know the difference between a code and a standard. A code is a legally enforceable specification. A code is a legally enforceable specification. For example, if you are designing a boiler, there is something called the Indian Boiler Code. Whenever you design a boiler, you should design a boiler according to that code only. If you design otherwise, you can be punished under the code of law. All designers must know this. For many products, there are codes available. You should know about the codes if you are venturing to design a boat. Suppose you are designing a bridge. Okay, there is a code available for bridge design. In fact, multiple codes are available for bridge design. So, if you are designing a bridge, you have to satisfy the codes. Codes are legally enforceable. If at some point of time, if somebody could prove that you have designed the product but you have not adhered to the code, then you are punishable under the law. You cannot say that, no, I just generated a drawing and gave. No. You have designed something, okay, for which a code exists, you have not adhered to the code, then you are punishable. On the other hand, there are many standards. How to design a bolt and nut? There are standards available. These standards they are sort of recommendations. These are standard practices. These standards exist to make your job easy. Okay. It is preferable to follow the standards. In your wisdom, if you feel that no, the standard is not good, I want to deviate, you are welcome. But you cannot deviate a code. Standards, they are for your convenience. If you choose to deviate, fine. It is up to you. It is your wisdom. But you cannot deviate a code. So you have to study all these codes and standards. They are maintained by who maintains the codes and standards for India? Can somebody say? Yes, somebody said that? Yes? ISO. ISO is International Standards Organization. We had an organization called Indian Standards, ISI, Indian Standards Institution. But Indian Standards Institution it doesn't exist anymore. It was closed. You have Bureau of Indian Standards, BIS. Bureau of Indian Standards. Any product that you design in India, if it has a code, you have to get an appropriate code from the Bureau of Indian Standards and then use it. Anybody knows where the Bureau of Indian Standards is located in Chennai? These are all the things engineers must know. Okay, it is located in Taramani, near modern bread factory. In the area of Central Polytechnic is there, Women's Polytechnic is there. In that area, you have the Bureau of Indian Standards located. It has a huge library. It provides all the international standards also accessible to you. Okay. For any product that you design, you must check whether the codes are available or standards are available. You can use the standard, but you must use the code if it exists. Then there are various agencies, manufacturers, associations who maintain census of manufacturers. This Moody's Industrial Review, it is a sort of an organization involved in industrial intelligence. Okay, it is not available free of cost. You can check. I don't know. I may not be very updated. At least 2-3 years back, this was not available online free of cost. This is a review which is available. You have to subscribe very heavily. It is a sort of journal which provides you an insider view into various industries. Okay, it is a Moody's Industrial Review. Then customer reports, magazines. There are various trade magazines available. You have various trade magazines. In our library, we have some 3-4 trade magazines. American Machinist, Tool Maker. These are all trade magazines involved in manufacturing. Okay. Automobile News is another trade magazine about automobile manufacturing. American Machinist. American Machinist is a trade magazine. It covers everything about manufacturing. Any issue you have in manufacturing, you can refer to American Machinist. These are trade magazines which are available. Then there are patents. Patents nowadays can be accessed online. You have various patent offices that provide you information on various existing patents. Okay. If a patent is existing, you can buy it and then use it for your product. Next slide, please. So you have various market research databases. Dialogue is another website. Okay. These are all the various informations which you can relay for doing the benchmarking. Next slide, please. You have the World Wide Web, vendors, technical specialists, experts. These are all informal source of information. Networking plays an important role in today's society. Networking means communicating and keeping contact with people. They provide a lot of information. Okay. Academic experts. Generally, universities are considered, if not in India, in Europe and America, universities are considered as repositories of information and knowledge. So whenever industry, they have some problem, they approach academicians, they provide inputs and the various sources from which they can get the data. So another important source, which is not listed here, are the universities. Next slide, please. Now next comes the teardown of multiple products. We have identified what to look for. The first, you have identified what to look for. The second, you have identified where to look for. What are all the products you are going to compare. Okay. Then the third, you have gathered all the secondary information. The fourth and the heart of the benchmarking process is you get the product, break it open, tear it down, see how it works. About this we have seen in detail, so I am skipping this slide. We have studied exclusively about the product teardown, so I am not going into the details. I will go to the next slide. Is it okay? You know what product teardown is, what are the outputs. Next. Benchmark by function. Okay, you have done it. You have broken open, you have performed the product teardown. What are you going to do from that? We have identified various functions. And please remember, by comparing these functions to the voice of the customer, you can identify what are the crucial functions that I should look for. Now, after doing product teardown, I can identify function by function who is the best performer in that product. Function by function, not as a whole product. Function by function, who is performing very well and who is leading the domain. So, you have to prepare a summary of performance by function. Then, you have to establish if there exists few new product functions. Certain products may have few additional functions which they perform, which may not be existing in other products. So only if you compare function by function, you may miss out that. So you have to establish the new product functions that are available also. Then you have to quantify the performance. This is the most difficult part of the benchmarking. You have to quantify the performance. Everything we are happy only when we give a number. Please believe me, giving numbers is the most difficult job. You submit 200 assignments to me and then ask me to give a number. Please believe me, with all humility I tell you, it is the most imperfect job that I do. assigning marks. Okay, how do I go through a paper in 5 minutes and then assign a mark which you might have worked for 5 hours or 6 hours, or which you might have copied in 5 seconds or 10 seconds? Okay, I am supposed to give a number to it, number to the performance. It is a difficult task. Quantifying anything is very, very difficult, believe me. Quantifying, attributing some definite number is very, very difficult. But you have to do it, then only the process is scientific. The process is complete. So for example, certain products, they have a good aesthetic appearance. How do I quantify aesthetics? How do I quantify appearance? Customer had said the product must look nice. It must be aesthetically pleasing. This is one of the important points of the customer. You have identified 10 different products. I want to compare them from the aesthetics point of view. Which is most appealing? How do you do that? How do you attribute numbers? So probably I may have to take various opinions, okay, form a pool of people who will evaluate the appearance of various products by numbers ranging from 1 to 9, 1 being the least, 9 being the best, and then you have to attribute a number for appearance. Then only you can probably position how your product might look like. So, performance measurement is very, very important, and quantifying everything is very, very essential. Next slide, please. Then, as the final step, you establish the best-in-class competitors by function. For every function, not for the whole product, for every function, you identify who is doing the best job. Which product is giving the maximum output, maximum performance. So, at the end of the day, after performing all these 6 steps, what will you have? At the end of the day, after performing all these 6 steps, I will know. Suppose, say I am designing an automobile. In fuel efficiency, this particular product is doing extremely well. In braking, this particular product is doing extremely well. So what is the fuel efficiency that product gives? This product gives a fuel efficiency of, say, 70 kilometers per liter. What is the braking characteristics that this particular, another product, not necessarily the same product, in braking characteristics, some other product is performing the best. What is that? That I can take. So by comparing the different functionalities of different competitors, I can arrive at what my product is going to perform. And that is why I said competitive benchmarking leads to specifically arriving at the specification of your product. Generally, competitive benchmarking results in drawing down the technical specification. The next step, it is not actually a step. Next slide, please. The next slide, it gives you, it is a byproduct of benchmarking. It gives you an idea how the whole industry is moving. Okay? Where people are concentrating, where things are changing very fast. So this gives you a sort of peep into the future. This is also very essential if you want to be alert. Okay, if you don't want to fail and if you want to be on guard, you should always try to have a look into the future, how things are going, how things are moving, and in what directions things are likely to change very fast. These things also you must know. Competitive benchmarking also facilitates that. Now, I don't know whether, will it work here? No. I cannot access internet, yeah. have few interesting websites. Okay. Before I go to the assignment, I have just downloaded some able to do it now. Okay. So probably I have stored all the files, but still it is not coming. We will check it up. You can go to the websites. You can choose any product that you want. Okay. There are various filters available. You can compare their technical specifications. Okay. Now what I am going to do is, for the rest of the class, we have to benchmark. Now today, as part of your second assignment for this term, you will be benchmarking the wind turbines. You will be benchmarking the wind turbines. Okay. So you may not have much of input on wind turbines. So I thought I will show you some 2 videos on wind turbines and provide you 2 major players in the wind turbine industry all over the world. Okay. So I will provide few other inputs also. So what I want you to do is, I want you to perform a competitive benchmarking on 2 megawatt wind turbine. Okay. I want you to perform, all of you will be doing it, again no copying. You have to do a competitive benchmarking on 2 megawatt wind turbine. Plus, please don't come and ask me, sir, you give me each 2 megawatt wind turbine, we will perform the product teardown. No, I cannot afford that. Okay, a 2 megawatt wind turbine will typically cost somewhere around a 2 megawatt wind turbine will cost around 75 crores. Okay. So forget about providing you with a wind turbine so that you can perform product here. So that's not possible. So you have to get the maximum information from the internet. For these 2, I will provide some sample information. That is not all. I will show you some sample information for these 2 products, but that is not all. You have to gather maximum information on these 2 products. Okay. I will not give you the components. A 20 rupees I can collect from you and then give you a toy for doing the assignment, but not wind turbine. It's not always. Okay. And please believe me, you won't be able to keep it anywhere. Okay. You cannot keep it in your house. Okay, probably I have to provide you something like a football ground for each one of you to keep it. Because wind turbines are so huge. I don't know whether this video which I am going to show you will give you an idea. Let us see. Sir, is it coming? Please listen carefully. There is also some audio. So my colleagues here, they have managed to get the internet access. So probably I can show you. Okay. So I just go to what is the website I told you? .in.com. India.com. But please note, these are all studies performed with the product specifications alone. They don't do any product teardown or anything. Every product in the market will have a published specifications, and these comparisons are performed based on the declared product specifications. What is missing in these comparisons? Yes, one important step is missing in these comparisons. What is that? The product teardown. Okay. Right, you can select your product. Air conditioners, air coolers, audio system, Blu-ray players, Bluetooth headsets, cam cards. No, I am not that greedy. Let's try to do something technical. Digital projectors. Okay, digital projectors are these are digital projectors. Okay, you can at leisure go to this website, get the details. Okay, digital projectors. These are the various brands available. You give me the details of all the digital projectors that are less than 50,000 rupees. Okay. I'm just saying, give me the details of all the digital projectors less than 50,000 rupees. Now the comparison is available based on the performance. So it will give you probably what is the luminescence of various projectors. What is the cost? Okay. So you have the three models. Okay. What is the resolution? What is the illumination? What is the contrast ratio? What is the aspect ratio? The various models are compared. Whether keystone correction is available, whether real projection is possible. Real projection is I am projecting now from the front. Whether can I project from the rear? Whether that is possible. So all these things are given in this. So this gives you an idea to learn about the technical specifications of products. Many times we will be using products without knowing the technical specs. It gives you an idea to learn about the various technical specifications of the products. Is it okay? You can go to the website and see whatever product you want. For various products, you can check and then find out how they compare. Okay, can we please close it? No, keep it only. Close it and then.
Provide enough power for thousands who live in the surrounding desert communities, including Palm Springs. Meeting a sustained wind of 13 miles per hour, these 15 to 20 ton generators stand up to 150 feet high with blades 100 feet length. Each windmill can produce 300 kilowatts an hour, enough energy for a typical household for a month. With a cost of over $300,000 each, these wind turbines were engineered by NASA and are maintained with the help of local and state subsidies. Over the years, many windmills have been replaced by bigger, more efficient models, but they still remain planted closely together to create this unique.
Close it. Third one, yes.
Welcome. In this video, we'll show you the layout of a typical wind turbine generator as found on wind farms across the world. Now, exact designs do vary, but almost all the turbines in use today are horizontal axis machines which have a 3-bladed rotor spinning in a vertical plane attached to the front of a box which we call the nacelle after the fairing around an aircraft engine. And in this nacelle we have the generator, often a gearbox, and occasionally a high voltage transformer. And the whole thing sits on top of the tower, which is supposed to be there to keep the blades from digging a hole. We tend to class turbines by their power output.
Now the top tower,
Bombs might use
that will be at the size of your classroom.
each producing 400, 600 kilowatts each.
What you see here on top,
Producing,
this will be the size of your classroom.
apart from the physical scale, there are arrays of forces. So let's start by looking at the turbine produced by 35 to 45 meters tall, and at the base you'll often find 2 doors. The lower door takes you into a secured compartment where we have a high voltage step-up transformer. The generator at the top of the turbine is producing about 690 volts, and this transformer converts that into several thousand volts to send it more efficiently to the substation. The main entrance to the turbine is at first floor level, and there we find the control cabinet and the base of a ladder, or a series of ladders. Often in these smaller turbines, the ladders run to a series of platforms and they change sides at each platform to give you a rest area and a bit of fall protection. Platforms are generally just wooden discs suspended inside the tower walls, and they might have a trapdoor or a set of guardrails and a gate depending on how the ladders are arranged. The main run of cables goes up the wall of the tower, dodging past any intermediate junctions, because obviously the towers can't be delivered in a single 40-metre long section. They come in 20-metre long sections that are bolted together with a lot of nuts and bolts. But as we move higher and higher through the platforms, they're getting slowly narrower and narrower, the ladders are getting a little bit closer together, but eventually the main cables stop being attached to the wall and they hang freely in the centre of the tower so they can twist as the nacelle rotates to face the wind. If they twist too many times, the nacelle will spin itself around to remove the twist. But as we move up, now the cable goes through a hole in the centre of each platform, and at the top of the tower we have a steel platform with a sealed trapdoor, which we call the yaw platform. Just above that we have the yaw ring with the bearings that allow the nacelle and the rotors to rotate around to face the wind. And this sealed platform acts as a bit of fire protection, also avoids people falling back down the tower, because at the top of the nacelle we simply have a hole which we climb. And the nacelle in this case is a spately tapered tube. At the back we have the wind sensors which give us speed and direction and allow the turbine to face into the wind and to change the angle of the blades. The nacelle itself is just a fiberglass tube. At the front we have a similar fiberglass cowl protecting the hub, which is a steel casting on which we have bolted our 3 blades, and the blades can turn or pitch so that the angle they form with the wind can be varied. Out of the back of the hull we have a shaft which leads into the gearbox, then a high-speed shaft through a brake into a generator, and that generator then supplies the electrical power, as I say, at about 690 volts all the way back down the tower to the base. And right at the back we have a cooling fan, as we're generating 500,000 watts of energy inside the nacelle. Some of that is wasted heat, and without an efficient cooling system there is the potential for the turbine to catch fire. Now, the layout of a larger turbine is broadly similar, but some of the components are in different places. So let's start by looking at the tower section of a typical 2 megawatt turbine. Where we place the high voltage transformers in multi-megawatt turbines is a lot more variable. Quite frankly, we have a lot more room, so we can decide if they can be in the nacelle, they can be at the base of the tower, they can be on platform 1 in the basement, they can be outside in a hut. In this example, the transformer's at the top, so when we go into our door, the one thing we'll not find is a transformer. We do have the high voltage switches, this case on platform 2, but on the entrance platform we have the usual control cabinet and a lift, a little green box. And that lift will take 2 people to the top of the tower, or nearly to the top, without them having to climb the single, very, very long ladder. Almost all large turbines will just have a single run of ladder for the majority of the run of the tower. It will have a wire or rail system fall arrest device fitted to it, but it is still a long slog of the ladder, which is one of the reasons why service lifts are so important. And again, the tower's in sections so that it can be delivered around the country without demolishing villages. Sometimes, if we're running a long distance and we haven't got room for a proper platform, we can put a half moon in place. No fall protection on the platform, but we assume you will keep your lanyards connected at this point because it's quite a long way down. The cable again breaks free from its mounting and hangs in the centre of the tower for the last 10-20 metres or so that it can rotate as the nacelle yaws into the wind. And the lift eventually runs out of space. Remember, the tower is getting narrower and narrower as we get to the top. So the lift tends to park itself about half a platform from the top, and we have a normal ladder which then leads to the yaw platform, and then it starts looking very much like the smaller turbine did. We have a yaw ring bolted to the underside of the nacelle, joining it to the top of the tower. A series of disc brakes run around that yaw ring to lock it in position when the wind isn't changing direction. And when it is, we have a series of either electric or hydraulic motors that rotate the entire mechanism around on the top of the tower. The layout of a multi-megawatt nacelle is again more variable than for a smaller version. We always have to have a generator, but we may not have to have a transformer. In a few cases, such as the famous Engg-shaped nacelle, we don't even need a gearbox. They're direct drive. We just have a shaft linking to a motor, and then lots of extremely complicated electronics to condition that power connection to the grid. But in most cases we need, the same as we need in the small turbine, gearbox, generator, possibly a transformer, all in a fiberglass box. And in our example, we're looking at a typical design used by a number of manufacturers where we have a nacelle that's 3 metres high, 2.5 metres wide, 7 or 8 metres long. It's a fiberglass box about the size of a side saw. As before, we have our wind sensors on the roof as far away as possible from the dirty air cast off by the blades as they spin round. This design is just a fiberglass box with a flat roof. We access the roof through a couple of skylights. Some designs are like before, big cylinder with 2 opening doors. Some have an entire roof section which opens, rather like an old camper van. if we take the skin off the box, inside we have the same kind of components we had before. They're just bigger, and there's a little bit more room, so that's laid out a bit differently. The only additional component up here is those 3 green cylinders at the back. That's our high voltage transformer, which used to be at the base of the tower. Now we've removed a lot of the control systems and the hydraulic systems that would just clutter up the pretty picture. We've added in a bloke for scale, but most of the big components are still here. If we look at the very front of the nacelle, we have a couple of bearings which support the main shaft, which is a hollow tube, 50, 60, 70 centimetres in diameter. It's hollow so that we can get electrical cables in through this main shaft into the hub to drive all the control systems inside the hub. And we have a couple of pins on the first bearing that lock the main rotor in position when you need to access the hub. It's a safety feature. If you're in there and it starts rotating, it gets scary. So our main shaft drives our gearbox, which is mounted centrally because it's often the heaviest component. Out of the back comes a high-speed shaft, as before. That's where the braking system is. High-speed shaft then drives the generator, which is usually oil-filled. The generator then supplies 690 volts, in this case into our transformer, which is sitting right next to it. That high-voltage signal then passes through the switchgear in the cabinet, down the dropper cable, straight down to the bottom of the tower, through those switches on platform 2 and off to the substation. And that, as an overview, is pretty much all there is to it. The only thing left to talk about are the blades, obviously, to actually do the work. We still have 3 of them. They still pitch, in other words, they twist on themselves to line up with the wind. And you access the hub through the gap between this fiberglass cowl and the cast hub. It's a bit of a wriggle, but you wriggle through, usually feet first, crawl through the hole in the middle of the hub, and inside the hub we'll find the control electronics, the pumps, the motors, the batteries, to control the pitch of each blade, rotating it on its own bearing to set the optimum angle for the wind. We turn the blades through 90 degrees so they're edge onto the wind. There's no net turning force. It's a process called feathering, and the turbine will stop. Obviously there is a vast amount more going on inside a turbine, lots of wiring and control systems and lights and sensors, fire extinguishers, etc. But that is basically it, the general overview of most turbines that you find on wind farms today. Designs for the future will be significantly different, but at the moment it's a windmill on a stick.
Now, there are 2 major players in wind turbine manufacturing. Can somebody tell any names? Vestas, then Switzerland. Okay. There are a couple of other Indian companies also. We had, yes? Somebody said something? Any? Okay. And many Indian players, they are absorbed by multinationals. NEPC is one such case. They don't exist anymore. Okay. Good. Good that you said it. There are a couple of small players also, even today in India. Now I have taken the case of, can I go to the PowerPoint presentation? The last one. Before that. Okay. Now this is the Vestas.com gives you the website of Vestas, and Switzerland.com gives you the website of Switzerland. I have taken approximately the technical brochures of 2 megawatt turbines. These technical brochures are available as PDF files in that folder again. No. L50. There are 2 PDF files. These are the technical brochures. You should know how to read a technical brochure also. That is also part of this course. Can you open it? So you can zoom every page. So this is, I'm sorry, this is the second 7 megawatt. There is another file which is 2 megawatt. So this is the Suzlon 2.1 megawatt. Can you go to the next page, please? Next page. Yes. So it completely describes, okay, about the group, about the company. Yes, next page. Next. Okay. These are general corporate informations. Next. Next. Here starts the technical details. Okay, there are many issues associated in a wind turbine. So the technical details are given. Okay, the overall design details are given. Next, technical. This is a very important graph for any wind turbine. See, typically, when the wind velocity is below certain level, okay, all the wind turbines must stop. Typically, when the wind velocity is, say, less than 3.5 meters per second, this is called the cutoff wind speed. Okay, if the wind velocity is less than 3.5 meters per second, it is not worth generating the power. Okay, the wind energy available itself is so small, it is not worth generating the power. You will be spending more power rather than generating power. Okay, so the system must cut off. There is no point in rotating, because when it rotates, something will wear, there will be wear and tear taking place, there will be associated problems. So the windmill, it will no more resist the wind, it will align itself with the direction of the wind. Okay, by pitching the blades, you will align the blades in such a way that it doesn't resist the wind blow. Okay. Now after that, as the wind speed increases, okay, today also Chief Minister has started, she had mentioned that by June, July, the power problem in Chennai and Tamil Nadu may slowly come back to normalcy. The primary dependence, do you know anything? After April 31st, okay, the windmills are supposed to generate power. Okay, one of the hope of Tamil Nadu now is in the wind. Okay, we have about a couple of scores of hundreds of megawatts of windmills already in grid, but now you don't get any power from the windmill because there is no enough wind. The cutoff wind speed will be crossed sometime in April. It is expected to cross by sometime in April end, so that the wind farm may come and help us. One of my colleagues, he reminded me about the impending energy crisis and the relevance of windmills. So this may happen sometime in April end. So, and after about 12 meters per second, okay, 12 meters per second, it generates the rated power. So this is the region which produces the maximum power in any windmill. Every windmill will have a typical characteristics. This is one important technical parameter to compare. Now I leave it to you. Okay, you perform not more than 2 pages, a competitive benchmarking of any 2 windmills of your choice. They must be comparable. There is no point in comparing an 8 megawatt windmill with a 750 kilowatt windmill. No. Okay, they should be of comparable ratings. They must be, and you have to perform a competitive benchmark. Try to get maximum information possible in the submitted. No more than 2 pages, but let the 2 pages be rich. Is it okay? I'm not either for Suzlon or B.S.ABDUR. You can choose any 2. I have just suggested 2. Okay. You can choose any 2 windmills, preferably because nowadays the industrial trend is, I don't know whether you must know this also, the technological demonstration for 8 megawatt windmills have taken place. These huge megawatt windmills are basically offshore structures. People have stopped constructing windmills on the land. Now they have gone to offshore structures in the sea. Because in the land the main problem is there will be some structure which obstructs the flow of wind. In sea you don't have any such thing. So already the technology have been established in designing and establishing the oil rigs. So the floating oil rigs, we know the technology. So in these oil rigs, can we erect a huge windmill? That is how the technology has started, and we have. Now the high capacity windmills are offshore structures. Okay, you have wind farms, offshore wind farms which generate even 1000 megawatts. You have offshore wind farms which together generate 1000 megawatts. Okay. Now the maximum power of a windmill is now, as technology stands today, it is about 8 to 10 megawatts. But most popular, widely used windmills are typically in the range of 2 megawatt. That is why I suggested a 2 megawatt windmill. Okay, we have fractional megawatts windmills also available, but ideal will be a 2 megawatt windmill because that is the industrial leader today. So you can choose. Take 2 windmills of comparable specifications and perform a competitive benchmarking. That is your term assignment. That is the assignment 2 of this term. Is it okay? Thank you.